As we've seen, the early modern period has been one of radical change for Europe and, by extension, for the world, starting with the conquest of the New World and the discovery of all of these people and plants and animals that Europeans had never seen before. That leading to increased curiosity about the world and an urge to kind of understand it better, coupled with rediscovering classical Roman and Greek science and knowledge in the Renaissance, and increased skepticism, plus the ability to share information that came from the printing press. And all of these changes led to what was, in my opinion, probably the most important intellectual revolution of all of them, the scientific revolution, which is a period of time, not a day, right? A period of time from roughly 1540 to roughly the 1700s, in which a handful of brilliant individuals laid the foundations for science as we know it today. Some historians consider the development of modern science the most important event in the intellectual history of humankind, period. These series of events is called the scientific revolution. It's called a revolution, right? Because modern science was a radical new idea with a completely different way of looking at the world and understanding it. And critically, it didn't just apply to the discoveries that were made, and it didn't just apply to science. The scientific revolution gave us a way, a system, a method, a scientific method that we can use to test theories, to distinguish from true and false hypotheses, and to really get a firm handle about how the universe works, how the physical world works, what reality is, and to separate what we know from what we don't. Before the scientific revolution, most educated people who studied the world took guidance from the explanations given by authorities, like ancient Greek writers, perhaps, but most especially from the Catholic Church and what was written in the Bible. After the scientific revolution, educated people placed way more importance on what they observed and less on what they were told to be true. They gained knowledge by observing the world around them, experimenting, and coming up with logical explanations for what they saw, whether or not it was what they were looking for to begin with. This change of mind set the groundwork for multiple intellectual revolutions that came after and for our modern world. I would also argue, looking around our contemporary world, that it is incomplete. And if only humanity could just get on board with this one change and learn its lessons, I think the world would be a radically better place. So, as we go through the lesson, think about, in what way does having an established method, a system to test received truths and establish facts, how might that potentially affect more than just science? How might that have political, economic, etc. kind of effects? To situate ourselves in time, the scientific revolution was a process, not an event, and it took place over literally hundreds of years. Contemporaneous with the Renaissance, the Protestant Reformation, and the age of absolute monarchy, so a time period where the Catholic Church and the kings and queens of Europe were incredibly strong. It began in 1543. There's a specific date, because that's when a man named Nicholas Copernicus debuted his heliocentric theory, this idea that the sun is at the center of our universe on Earth, and that the Earth revolves around it. This was a dramatic change in thought and belief about scientific theory and also the place of the Earth and humanity in the universe. Before this, people believed what the Church and ancient Greeks believed, that the sun revolved around the Earth. The Church claimed that humanity was at the center of God's creation, and so it would make sense that everything else revolved around us. This was backed up with some ancient Greek early scientific thinking, and that was something that the Catholic Church had adopted into its doctrine and claimed to be true. When in fact, as we now know, that's not how it works. Earth revolves around the sun. Nicholas Copernicus was the first to theorize this. Years later, a man named Galileo would test this theory by making observations with a telescope and prove it. And in that change, in that moment of proof that the Catholic Church had been wrong, that there's a way to find out what was true, we have the essence of the scientific revolution. So first, let's look at the change that this involved. Before the scientific revolution, people made sense of the world very differently. They believed that the natural world was random, that divine will, God, explained why things happen. If something bad happened, if the plague came, it was God punishing you. People didn't believe in progress, really. They just believed that life was kind of random and terrible and something to endure, and then eventually the world would end. The way that they thought about the world, their sources of knowledge, basically relied on what authority figures told them. People were very willing to believe what they were told and, make sense of their world from there. And the two authorities that really held sway over scientific knowledge at the time, first, what was written in the Bible, the holy text of Christianity, Catholics in the time, and second, ancient Greek thinkers that supported what was in the Bible and that the Catholic Church agreed with. So not all ancient Greek thinkers, just the ones that conformed to what the church had been teaching. The typical example is this question of whether Earth revolves around the sun or the sun revolves around the Earth. The Bible said that Earth is the center of creation, and the ancient Greeks thought that the sun revolved around the Earth. So the Catholic Church taught this as being true. As an effect of this way of thinking, there was no system for gaining or testing knowledge. People believed what they were told, and that was kind of the end of the story. As a result, people didn't understand the physical world, and so it seemed very random to them. People were really superstitious. And again, people didn't believe in progress. They didn't believe in the ability of humanity to really improve their world in a consistent way over the long term. During and after the scientific revolution, people began to see the world very, very differently. In terms of how people made sense of the world, then and now, during the scientific revolution to today, we now know that the natural world follows universal laws, and that math can help us understand or decode them. For our sources of knowledge, the modern scientific mindset questions assumptions and tests them using the scientific method, which involves observing, experimenting, and then confirming or dismissing hypotheses based on what we find. A great example for this at the time was the work of Copernicus and Galileo. Copernicus theorized that the Earth revolved around the sun, which is true. Galileo tested it with a telescope, making observations, so he ran an experiment, and he proved that it was true. So now we know. The effects of this kind of change in the approach to the physical world and understanding reality were huge. This threatened the power of the church by proving parts of what it claimed wrong and providing a reliable method that you can use in all kinds of contexts to test claims in the future. So not only was the church proven wrong, which damages its credibility pretty big, but also we can now test anything that people tell us using this method. This also threatens the power of absolute monarchs, because absolute monarchs depended on this divine right idea for legitimacy, the idea that they're king because God says so. Well, if the Catholic Church isn't right about everything, maybe it's not right about that either. Second, this emphasis on reason, the ability to think through problems using logic, in the long run, had thinkers turning their attention to finding a more rational basis for government. It's silly to us to think that people give their loyalty and a lot of tax money to kings because the king says that God says that the king and his whole family are supposed to be there, ruling over everybody. A more rational basis for government would ask, what does the king do for us? What should the king do for us? And this is kind of the seed that would turn into a movement called the Enlightenment that basically applied the scientific revolution to problems of society and government, which we'll be learning about next. So, to sum up all of that complicated information, the big change that we're talking about is a way of thinking and testing reality. Before the scientific revolution, knowledge came from religion and authority, and there was no organized method for research, for testing claims. Then, the big change, the key to all of this, was a new system for thinking called the scientific method. Scientific method calls upon us to not just believe everything we hear, to test things, to question yourself and your own assumption, to keep ideas that are proven true, and to throw away ideas that we now find to be flawed. The scientific revolution created this desire to test theories to explain the natural world, and a reliable standard for testing theories. And that reliable standard is this scientific method, a process by which knowledge can be tested and confirmed or refuted through observing the natural world and through systematic experimentation. We still use it in science class. So after the scientific revolution, instead of just believing what we're told, knowledge now comes from logic, observation, experimentation, and the scientific method. So we follow rules for knowing what is true and what is not. One of the keys to the scientific revolution that bears repeating because people often forget it, even nowadays, is that it involves becoming really comfortable with the unknown, because the unknown is like the playground for scientists. It's where discoveries can be made. But first you have to admit that you don't know everything. And there's this great quote on the slide that I'll read to you. It says, "One might say science is the sum total of our knowledge of the universe, the great library of the known. But the practice of science happens at the border between the known and the unknown. Standing on the shoulders of giants, we peer into the darkness with eyes open, not in fear, but in wonder." Just like reason and logic follow rules that reliably lead to understanding the truth, so does scientific experimentation, so long as you hold fast to the idea that you never claim to know something to be true when you don't in fact know it to be true. Becoming comfortable with not knowing things, with the unknown, takes a little time and a little practice, but it's true and it's honest, and it's better than filling in comforting ideas that may be false. So, my call to you all, dear students, is to get very comfortable embracing the unknown. By doing this, by casting aside truths dictated from tradition or religion, and embracing this uncomfortable idea of the unknown, and then setting out to explore, reason through, and test reality, the physical world and the universe, and then by sharing their research and building on it, scientists over the span of generations, who were back then called natural philosophers, made a series of groundbreaking discoveries that together would form the basis of what we now call the scientific revolution. It started with astronomy with Copernicus, but if you want to pause the slide here and just have a look, we involve discoveries about physics, about establishing a method based on observation and experiment to test reality. Politics even begins to enter the scene in the middle of all of this change. And then mathematics, we have the invention of calculus. Basically, math and science classes became more real and therefore more difficult as a result of what happened in these years. Let's go ahead and pause the slide here and have a look at a selection, not a complete list, a selection of discoveries, and then press play again. To orient ourselves in terms of space, have a look at where all of these scientists were working. Thanks to the printing press, scientists were able to collaborate across state lines and across generations to build on each other's research and develop the scientific revolution, which again is based on observation, questioning, hypothesis, experiment, analysis, and conclusions. Of course, all of this might make it seem like the work of the scientific revolution was complete, that once it was understood, who wouldn't adopt the scientific method? It obviously works. And yet, even a brief look at the modern world will show you that it's still filled with unscientific thinking, pseudoscience, which are unscientific ideas dressed up as science, but that don't actually follow the rules of science, and logical fallacies. Conspiracy theories, for example, rely on the logical fallacy of burden of proof. If you claim something, it is on you to prove it, is what logic says. And conspiracies like the stupid flat earth theory rely on the idea that it's not your job to prove it. If the earth isn't flat, prove me wrong, kind of thing. So watch out for that. That is unscientific thinking, which will reliably lead people to bad conclusions. Another common unscientific tendency that people in all walks of life and all contexts are tempted to follow involves confirmation bias, which means instead of taking evidence where it leads you and embracing conclusions, starting with the conclusion you want, and then just cherry picking evidence that supports your ideas while ignoring or rejecting anything that might challenge them. A true scientific approach involves accepting that you might be wrong and accepting evidence that proves that your ideas are false and then adapting to that new reality. Always remember that falsifiability is a key to scientific thought. A hypothesis can be considered scientific theory only if it can be disproved. And keep an eye out for the distinction between science and pseudoscience. Science involves a willing to change with new evidence. You should be very ready to change your perspective as evidence tells you that you should. It involves peer review, so like multiple people looking at your experiment and hypothesis and confirming your conclusions. It takes account of all new discoveries, and it invites criticism, because the goal of science isn't to be right, it is to find the truth, and that is a very, very important distinction. Scientific results are verifiable. That means other people can run the same experiments and get towards the same conclusions. It limits claims of usefulness, and it involves accurate measurements. Pseudoscience, or fake science, is very different. It involves fixed ideas with no peer review. It selects only favorable discoveries and sees criticism as conspiracy. It involves non-repeatable results. Often, it'll make claims of widespread usefulness and use ballpark measurements, so it's not very precise. Even back during the scientific revolution, it wasn't smooth sailing for these natural philosophers either. There was a lot of pushback, especially because, remember, what they were saying often contradicted what the church had been claiming for years. Galileo, for example, made observations using a telescope that proved the Earth rotates around the sun, not the other way around. He was right, and he was hauled in front of the Inquisition anyway. On the slide, you see a brief copy of his indictment from his trial. In terms of the charges, here's what the Catholic Church said Galileo did wrong. It says, "You, Galileo, were denounced in 1615 for holding as true a false doctrine taught by many," and this is the church talking, remember, "namely, that the sun is immovable in the center of the world, and that the earth moves, and also with diurnal motion, and for having pupils or students who you instructed the same opinions, and for maintaining a correspondence on the same topic with some German mathematicians, and for publishing certain letters on the sunspots, in which you developed the same doctrine as true, and for answering the objections which were continually produced from the Holy Scriptures, by glosing the said Scriptures according to your own meaning. And whereas thereupon was produced the copy of a writing in form of a letter professedly written by you to a person formerly your pupil, in which, following the hypothesis of Copernicus, you include several propositions contrary to the true sense and authority of the Holy Scriptures. In other words, Galileo, you claimed something that is against what the church had been saying, and you told other people, and you published it. And we're saying that's bad. In the pink box on the top right, you'll see what the Catholic Church wanted to correct about what Galileo had published. The Catholic Church wanted people to believe that, number one, the proposition that the sun is in the center of the world and immovable from its place is absurd, philosophically false, and formally heretical because it is expressly contrary to the Holy Scriptures. So in other words, if the Bible says it's wrong, then it's wrong, and that's the end of the story. 2, the proposition that the earth is not the center of the world, nor immovable, but that it moves, and also with diurnal action, is also absurd, philosophically false, and theologically considered at least erroneous in faith. And again, you see these two competing visions of how to find truth. Galileo did experiments and came to a conclusion. The church is saying, well, no, the scriptures are saying it's wrong, and so it's wrong, and that's the end of it. In terms of their judgment, on the bottom in the green box, therefore, we pronounce, judge, and declare that you, the said Galileo, have rendered yourself vehemently suspected by this holy office of heresy, which is, of having believed and held the doctrine, which is false and contrary to the holy and divine scriptures, that the sun is in the center of the world, and that it does not move from east to west, and that the earth does move, and is not the center of the world. And also, and here I think is actually the key, he was accused of heresy because he believed that an opinion can be held and supported as provable after it has been declared and finally decreed contrary to the Holy Scripture. In other words, his crime was contradicting Scripture and claiming that contradiction on the basis of scientific proof. This shows that scientists' discoveries were a direct challenge to the Catholic Church's authority. First, by valuing skepticism and experimentation over belief in church doctrine, which means asking why and demanding proof, which challenges authority, as teenagers worldwide know. Second, by proving a lot of what the church had been claiming about the world to be wrong, like the earth revolves around the sun, not the other way around as the church had claimed. For what it's worth, it took 350 years for the Catholic Church to admit that Galileo had been right, which I actually think is kind of funny. And the effects were beyond just science. So as you go through the lesson today, think about how having an established method to test received truths and established facts has the potential to affect more than just science, because our next lessons are going to be all about this. Finally, let's turn to the key points. There are 2 slides for today that cover what we have already discussed. So press pause on this slide, take down these definitions, then press play again. Here's slide 2. Because we're talking about a big change, it's always important to keep track of what life was like before versus what life was like after. So please press pause here and add this information to your notes. And here's everything on one slide in case anybody wants it.